Hello, hello. So we need to finish the notes that you took in your journal after the test today. And those notes basically center around this equation. That equation is Q equals MC delta T. I'm going to put a box around this guy. And let's define what all of these mean. Q represents heat energy, and that is in units of joules, which is a capital J. M stands for mass, and that is in units of grams. C, that is the specific heat, and it changes for every substance, and the units of it are joules all over grams degrees Celsius. So for every problem they'll give you the C. And T, temperature, that, I just said it, it means temperature. So temperature, and it's in degrees Celsius. Only the gases we did in Kelvin. Now, I like to actually rewrite this equation. This equation is Q equals MC delta T. And we know that delta means change. And if we're calculating the change in something, we're calculating final minus initial. So I like to rewrite this equation as Q equals MC TF minus TI. So that way I can see that it's two separate numbers. There's a final temperature that I need, and there's an initial or a starting temperature that I need. So we're going to do two examples. Example 1, calculate the heat energy absorbed when 25.0 grams of aluminum is raised from a temp of 21 degrees Celsius to 71 degrees Celsius. And then the C of aluminum, so C stands for specific heat. So the C of aluminum I'm giving you is 0.90. The units are joules all over grams degrees Celsius. So I'm going to start off with my formula. My formula is Q equals MC delta T, which is just Q equals MC TF minus TI. So now I'm just going to go through and read across. Calculate the heat energy. That is Q. Q equals, I don't know. They wanted heat energy. Heat energy is Q. And notice the units are going to be in joules at the end. So it says we've got a 25 gram sample, so that's M. So mass equals 25.0 grams. It gives us two temperatures. It says from a temperature of 21 degrees Celsius to 71 degrees Celsius. So that means 21 degrees Celsius is my starting or my initial, and 71 degrees Celsius is my ending or my final. So TI equals 21 degrees Celsius, TF equals 71 degrees Celsius. So now that I have all my info, I can plug and chug. So Q is what I'm trying to find. M is 25.0. They gave me C, it's right here, it's 0.90. TF is 71. Oops, get rid of that guy. TF is 71 and TI is 21. So notice it's final minus initial. Final number, usually the second one they give you for temperature, minus the starting temperature, 21. So working through, first I'm going to worry about subtracting those. So 25.0, 0.90, 71 minus 21 is 50. And then you just multiply all those together, and your calculator spits out 1125. Since you guys have a sub and it's going to be difficult for me to do sig figs on this, I'm just going to tell you guys to give everything 3 sig figs for these problems. So that gives you 1130. So Q equals 1130, and it's joules, capital J. So notice once again, they wanted heat energy, which is Q, and the units of Q are in joules. That's why I said joules. Do one more example, and they'll be donezo. Is that something you guys say, donezo? I don't know, I guess I'll have to ask on Monday when I come back. Anyways, calculate the final temp of a 75-gram sample of water that absorbs 3,500 joules of heat and began at a temp of 22 degrees Celsius. Your specific heat of water is 4.186 joules per grams degrees Celsius. So I always start out these problems by writing my equation. So Q equals MC delta T. Rewrite it again. Q equals MC. Delta T is temperature final minus temperature initial. That makes it much easier for me to plug in. So it says calculate the final temperature. So they want TF. That's our question mark. They give me the mass of our sample at 75 grams. It's absorbing this much heat energy, so that's Q. So this, notice there's joules there, that is your Q. So Q equals 3,500 joules. It began at a temperature of 22 degrees Celsius. So that's my starting temperature. That's TI. It's 35. Oh, not joules. I just wrote the same thing. I'm sorry about that. My initial temperature is 22 degrees Celsius. So now that I have all my info, I'm going to plug and chug. So Q is 3,500. M is 75. C they gave me is 4.186. They want the final temperature, and they gave me the initial temperature is 22. This is what's a little tricky about this one. You need to solve for the parentheses first. So I need to get the parentheses on their own. So how I'm going to do that is I'm going to divide each side by 75 and 4.186. When I do so, my calculator spits out 11.11482 equals, and I'm left over with TF minus 22. And now, let me focus this. And now I want to solve for TF. So I'm going to add 22 to each side. So notice this is no longer a multiplication and division right here. It's addition and subtraction. So to get rid of the 22, I add it to each side, which gives me 33.148. I'm telling you just to give all of these problems 3 sig figs, just make it easy. So the final answer is TF equals 33.1 degrees Celsius. Okay? So hopefully you'll be able to practice more with that tomorrow in class. Hope you guys have a great evening.